Thank you all for coming this morning. I'm going to give a short talk about a long topic, live programming, a bit of history, because I find that we're in a mode now where a lot of people are inventing square wheels, and awareness of the history of ideas is important. So part of this is going to just be a reminder where some of these things come from, and some of it is going to be where they're going, and hopefully it will be of some interest. So, what is live programming? Well, the best way to show live programming is to really show it. And so basically, it's about evaluating things. At its root, it's things like this, right? Evaluators. So the point being that we don't have to simulate this. If we write this in a text file, well, okay, you went through grade school, you know how to simulate this, but real programs are more complicated, and we have computers so that they can compute for us rather than us simulating in our mind what they're going to do eventually when we deploy this in reality. So that's really all there is to it, right? We just want something that does this, and this has been around for a long time. Basically, this is a form of what's called a REPL, read eval print loop, and that's the source code for the original REPL, right? Ultimately, it's very, very simple. You loop, and each time you read something, which represents some piece of program code, you evaluate it, and you print it, and you keep on going. So everybody has loops, everybody can read stuff, and everybody can print stuff. What not everybody has is eval. So eval is the key thing here, right? Evaluation, being able to evaluate expressions in your programming language from within itself. That is what makes things live, and that is what makes all the difference. So this has been around for a very long time. So this is a teletype. I'm willing to bet that nobody in this audience has actually touched one. But I have. Oh, sorry, I didn't see you. Apologies, yes. Another one of my wrong bets. There's too many of those. The story of my life. But anyway, I learned to program on one of these gadgets, and I was very lucky to be given access to this valuable and sophisticated piece of equipment. And the funny thing is, primitive as it may seem, in some respects it was more advanced than the stuff that most developers are using today. Because what I did with this thing is I wrote basic programs, humble basic, easy to rag on, not a hugely sophisticated programming language, but it had a REPL. What you do, you type at this keyboard, you'd literally type. Hopefully you know what a typewriter is. And when you typed, it would hit the page and actually print things as you went on, and then it would answer back to you by printing on this paper, right? And every time you hit return, it would go slam, kind of, massive noise. And sometimes it would make even more noise, because when you saved your program, you may not see it here, but see this thing? That's the paper tape reader and printer. So if you wanted to save your program, you got a roll of paper tape, and it would punch it. So this is of some interest to archaeologists and others, but the point is, it had a REPL. That's better than Eclipse. Okay, so it's a very basic thing. It's a very, very basic property of your architecture, and if you have it, all kinds of things open up. And if you don't have it, no amount of thousands of wasted person years are going to make up for it. So, of course, that I probably shouldn't disclose when I worked on that thing, but it was about 1975 or so. And way before that, people had REPLs. APL, for example, the first implementation when it came up was a REPL. This isn't it. This is a newer one. I can tell because it doesn't have the line numbers in it. I can even tell you what this program does, believe it or not. It's getting the numbers 1 through 6, then it's turning them into a 2x3 array and assigning it to M1. And when you type M1, it prints it out. And this is very similar, except it's 1 to 12 and a 3x4 array, and then you multiply the whole array by 100, etc., etc. none of which really matters. Explain the syntax of APL is not something that anyone wants to do in public, and I don't claim to. It's been a long, long, long time since I had any use of APL, but it's a cool language in a lot of ways. But the point is, it was interactive. There was this notion of an APL workspace, and you can write programs, and you could see what they did, right, as opposed to simulating it in your head. So REPLs are the first step. They're a baby step, and a lot of talk about live programming today. People get all excited. They have a REPL. Yes, that's nice. But a REPL is basically a very, very elementary thing, and that's not really what this whole thing is about. Fundamentally, it's about moving from dealing with text to moving to dealing with an experience, with an interactive, dynamic experience, which will bring us to Smalltalk. So this is the Alto. That is the original personal computer, circa late 70s or something. And this is in some museum somewhere, and in the background they have some sheet which actually shows Smalltalk code. So several points to note here. When Smalltalk ran on this machine, that was all that ran. That and the microcode. This was the operating system. It was the whole thing. What that meant is when you have a live environment, you can control the entire environment. And why is that important? Let's again have a look. So here we are with our little evaluator, right? And as we change things, right, it evaluates and it gives us results. The result is a link. If I click on it, I get an object inspector. It tells me that this guy is printed as 21, it's an instance of number, and so forth. And all of this is good and well, but what's really interesting about this is the liveness of the environment. Even though this is just a subset of a particular program environment, the Newspeak environment, that app happens to run in the browser. Most of it doesn't. The full environment does not run in the browser for all kinds of reasons. But it does know to do some nice tricks. So we have this link here that says Inspect Presenter. If I click on that, I get another object inspector. But this is an object inspector on the GUI object that was presenting the thing I just saw. This is the actual presenter object that was presenting the number 21 that we were just looking at. And the nice thing about that is now I can find out how to control that, because now I know the class of the actual thing that's running that piece of GUI. So that's object presenter. And I can look at its source code. And I can do things to its source code. And I can change the source code. If I go look at another object now, it's turned green. What I've done here is I've changed the IDE from within itself, live, right? It's a very simple change. It's not an interesting change. There's a reason it's a very simple change, because I want the demo to work and I do not want to get confused programming in front of all you people, right? But the point is, if you didn't like some widget in Eclipse, what would you do if you wanted to achieve this? Well, you could go look in the source code and find out where the particular piece of source code that actually controlled this was, which we did here by simply asking it, show us the object, show us what class it is, and we know what source code is. In the case of Eclipse, you'd go look through the source code and try and figure this out. That shouldn't take you very long. I mean, we know it starts with public static void main. We can work our way from there. Come back to me when you're done. Of course, you're not done then. Then when you have this theory, and it's only a theory because you've had to simulate the code in your head as to what actually runs this widget, then you can make the change, and then you can build it. Then you can go on your honeymoon or whatever and come back when it's done building. And then you can start up the program again, and that only takes a few minutes. And then maybe you have to bring it to whatever state it was where this widget was actually displayed in that particular form and see if it worked. This is perhaps the reason that this whole sequence of events isn't commonly done, right? It's incredibly hard, because live programming is about reducing the feedback loop from, in this case, probably days to seconds. Other feedback loops aren't as bad, but all of live programming is basically about letting you interact with the computer, having it tell you what the code does rather than having to simulate it or wait for it to go through a long sequence of essentially irrelevant steps that you're so used to that you're blind to the fact that they're relevant, like building things and compiling things and so forth, right? It's all about making the thing something that you can interact with immediately. And it's nice if the system is metacircular and you can actually do it to itself, right? Most applications probably don't need to do that. You only need to do that when you're developing them. But it's nice as a programmer if your development environment has that flexibility. And a well-constructed live environment will do that for you. And so, back to our regularly scheduled program. So, of course, inspectors aren't new either. They're a bit newer than REPLs. I think they go back to about 1976, to Smalltalk 76. I won't swear to exactly if it was 76 or 7. I think Smalltalk 76 pretty much had all the basic features that you see in later Smalltalks. Certainly Smalltalk 80, a mere 35 years ago, all of this was well established, but it was probably there a few years earlier. So it's not really particularly new that you can, have an object inspector. An object inspector is, again, a lot like a REPL. It's an evaluator. But the nice thing about it, it's an evaluator in scope, right? You can actually see things that are at scope to that object, right? If we go back and now I'm doing impromptu demos that I didn't plan, but let's see. We're in a number, so we can say something like self times 2, right? So we're actually in the scope of this object. So that's nice. There's a lot more to these tools, however, than just what we've seen. So with that in mind, we're going to go look at what are we going to look at? This guy. So we may have to zoom in a bit on this. It's not great, but you can see. So obviously we can evaluate things. And this evaluator is a little different, right? It got us the result there, 7. Right? Notice there's a little difference, and this is a point of UI that is actually worth mentioning, right? Some of these, the original REPLs, you would type in a line, and then you'd press return, carriage return, and it would, in the case of the teletype, that really meant something, because it went, the carriage went back. That's why it's called return. You can put that in your list of obscure, useless historical trivia that you can amaze your friends with. But it was a line-by-line thing. You'd put in an expression, and then you'd evaluate it. The thing I showed you in the browser actually evaluates every sub-expression as you type it. That's something that wasn't very feasible when you had to actually type it onto paper, right? But sometimes it's actually useful to do that, because sometimes you want to actually have larger expressions that might have side effects, and you don't want everything being evaluated all the time. You want to actually be able to build up a large enough expression or a series of statements or something before you actually let it go. And a workspace is good for that, because in a workspace we can actually have multiple things that we type in. It's like this pad of useful things that we write down, right? There are similar things in other environments. And these are small variations. They're very easy to do. These workspaces here are really just object inspectors on an object that is suitably scoped to give you, the whole programming environment's in the namespace so you can evaluate useful things. But there are other things that you can do with these environments, and Smalltalk is a good example of an environment that's been reasonably live for a very long time and has evolved a lot of useful features, though honestly it evolved most of them at Xerox PARC up to 1980. It's been a bit refined since, and what I'm showing you is actually Newspeak, which is a descendant of that. Do we need all that noise behind us? I don't know. So here's another thing you can do, right? We have this expression. It's in red for a reason. It's in red because the IDE is telling me that this thing isn't defined. But if I insist on evaluating it, well, I get this thing which tells me that there was an error. For those of you in the back who might have trouble seeing this, it basically says, message not understood, blah, blah, blah. And if I click on this, I get a debugger. And Now, actually, I want to unzoom because I know I'm going to have to zoom this from a different angle to show what I want to show. I want to zoom about here, probably, because one of the nice things it lets me do, okay, we haven't zoomed back enough. Let's try this again. This says create missing method binary search for in, right? The point is, I got a no such method essentially. Unlike Java, I didn't get just an error. I got a trap where I can now add this method on the fly. Right? So if I click this, I have here a template for the method that I was calling. And I can go edit it. You know, it fills in sort of argument names and types, and the types don't matter, they're optional. But it filled them in based on the types of the arguments, the actual dynamic arguments that I got, right? How does it know that I'm going to have a symbol in an array? But I can probably decide to generalize these or whatever. And I can start, you know, typing things in because I sort of know this demo by heart. So also, well, mid, high. Yeah. So this is, you don't need to know the syntax for any of this, but I can save this, and I can go back, and I can try and evaluate this baby again. And now it stops, right? There was this halt in it. We go back to the debugger, we can actually look at this, right? This halt, that's essentially Smalltalk's way of putting in a breakpoint, right? And now I can start writing in code, right? I can decide that the low is going to be 1, and I can evaluate that, and look here, right? Watch this guy, right? So now low is 1, and that's high is going to be the size of the list, because I'm going to do this kind of binary search through its indexes, right? I can evaluate that, and you could argue that the flow here in the UI needs work, and I agree with you. This is Newspeak. It's an experimental system that I've been working on that changes a lot of things from Smalltalk, hopefully for the better, which is kind of hard because the bar is very high. And I can do things like the midpoint is going to be low plus high over 2. When I evaluate that, oh, this is not going to be a very good index because that's basically a fraction, right? So I made a mistake, and I detect it immediately while I'm writing the program. And so I know what to do. I can keep changing it. Okay, now I've got a midpoint, and I can keep going like this and basically build the program in the debugger. Now, I don't think you should always do that, but a lot of times it's really a useful thing to be able to do. So again, the essence of these things has been there for over 35 years. Why in the mid-90s were we still introducing tools that couldn't do that? Like when I was involved in for a long time, like Java? Don't ask me. I do know that at least at some point that wasn't the intent. There's this lovely document that is kind of hard to find now, which was one of the early, shall we call it, propaganda pieces for Java. And it had this line saying, the edit, compile, run, crash off the cliff cycle is over, because Java was supposed to fix that. Except that it didn't fix that, and I could speculate why in the end the actual shipping things did not do that, but that's kind of beside the point. But the fact is that we have a whole culture that ignored all this stuff and went off in a different direction, and we need to bring it back. And people are doing that, and you probably have heard some of the talks or seen some of the new tools that people are doing. There's a lot of activity in a lot of places. But this talk is partly to talk about what some of that is still overlooking, partly to tell you that it's not new and draw lessons from that, and partly to move on and speculate about what we can do in the future. So, in the interest of history, of course, Smalltalk isn't the only one. Like I said, the Lispers did a lot of stuff. In the 80s, they built these things, symbolic Lisp machines. There were several brands. There were several companies building dedicated hardware that ran these things, because running these things on stock hardware was kind of difficult at the time. The interesting thing now is you can actually get emulators that run in a web browser that let you see how these systems were, like actually old versions of like Smalltalk 76 or some of the Lisp machine operating systems. You can actually emulate them in emulation in a web browser today. They probably run faster than they did originally on this hardware. This toy cost, on the order of $100,000 in 1985, when $100,000 was real money. And when I was in grad school, they had one in a lab that was kept sort of off limits, and mere mortals couldn't really get to it because time had to be scheduled on it, and it was a real big deal. But the nice thing about it was, right, this was Lisp all the way down, just like the Alto was Smalltalk all the way down. Everything there was in Lisp, the operating system, the editor, the tools, files, whatever you want. And that meant that all the liveness, all the ability to change and modify and play with was in your hands. It was a computer that you could control, right? It was your computer to do what you wished with, which is very different when you buy a phone now and it isn't even your phone to do what you wish with, right? So we're losing something very important if we don't insist on these properties, and ideally as far down the stack as we can make them. Now, this is a demo I wanted to give for a long time, and I was looking for an excuse to give it, just not because it's useful, but because it is cute. So the point being that a lot of this is about writing code, but liveness is a property of systems in general, and it's not always just about directly writing code. So this is Squeak Smalltalk, this guy right here. Let's try and, now we need it so we can see. This is probably as big as I can make it and still control what I want to control. So this is this window right here. It's a Smalltalk class browser. It is essentially undergone only very minor changes since 1980. And, I'd argue that it should have undergone more changes, but that, again, is beside the point, right? And you can do things here, right? So you can evaluate. Here, we've got tests for collections, and the test is doing set new. And we can actually do this, and we get an object inspector that's a little different, but this is an object inspector in a set on a set in Squeak Smalltalk. And we can ask it things. We can ask to have it print its size, right? And that's its size, right? So all of this, again, this is very close to what existed in Smalltalk 80 and probably in Smalltalk 76, right? Back in the millennium, far, far long ago. But what I wanted to show you, Squeak Smalltalk has several weird things. There's a system called eToys, because the emphasis in Squeak was, for a long time, was on teaching children. In fact, Smalltalk originally was a lot about making programming so simple that children could learn to program, which is a good idea, because then even adults can learn to program, because we know who learns better, right? So one of the things they have is this eToys system, which lets you basically program. It's designed to program little animations and things, where you can take graphical objects and assign scripts to them and tell them how to behave, animate them and things. The point is that it applies to all graphical objects, including system windows, which is what this browser is set in. So I can run a script for it, and I can make noises, and I can make it rotate. And if I manage to grab what I'm trying to grab here while it's doing that, this requires a bit of dexterity. Yes, no. I want to get this baby to select stuff. Eventually, when I practice at home, I could do this, but it's moving a bit too quickly. Thank you. And now, it still works, right? Nothing has changed. There's no reason that the fact that I'm rotating should interact with all its functionality, right? If it's done right. How many systems are done right today? You tell me. Right, I can also, I can cause it to evaluate in itself and print itself. It all works while it does this. Now, this is not a terrible, useful thing in itself, right? But it does have some advantages. I can stop that. right? They're also, oops, let's unzoom a bit so I can see what I'm looking for, right? One of the properties, these little colorful things, they're called halos. They are part of the system that lets you manipulate these graphical objects. So for example, here I can rotate it so we can bring it back to its proper position. And this is, I can add scripts to it and I can do things, but I can also disassemble it. Let's see, I don't know what I've grabbed, but let's try and move it and see what it will do. Right, so, okay, here I've copied this thing, just a subset of the whole thing, but its focus is still wrong, apparently. I can probably focus on one of these guys. No, I wanted to get on the smallest bit. Let's try and move this. Yeah, so this apparently makes a copy. What I wanted was move, so one of these icons probably does that. I'm not sure which one. Change size, let's try that. That didn't do anything interesting. Let's try and delete it. Yeah, okay, we got rid of it. So, again, this doesn't seem immediately terribly useful, but think what this means. It means that your GUI and the GUI builder are built in, right? If you want to rearrange this, you can start editing it again live. You can take it apart, just as you could with a GUI builder, except all the pieces are fully functional, and you can apply this to a ready-made piece of software that you encounter. And obviously, you don't necessarily want this to be on all the time, because if it's on all the time, you can accidentally disassemble your window when you're trying to do something. I've seen this happen to people. So you do want to control it. But it's very much like physical objects, right? So you have a chair there or a table, and all these things can be taken apart. They're designed so they don't fall apart very easily. But there are mechanisms that you can apply. There's a tool you can take and grab a screw or something, and you can disassemble it. You have access to that. Physical reality is like that because it wasn't designed by software engineers. Otherwise, if we had, imagine if the universe was designed by software engineers. Well, it wouldn't exist, right? It would never get past the first, picosecond of the Big Bang. You'd have an instant crash long before that, right? The laws of physical reality are sometimes you could view them as constrained, but they do not allow, incoherent fantasies to exist, and so it's a good metaphor for us to use. But again, the point being, live systems, it goes beyond the code, right? It's the ability to get immediate feedback on whatever it is you're building, whatever it is you're designing, whether it's actual code or whether it's graphical artifacts, etc., etc. So there are a few more mechanisms that I wanted to talk about that, again, aren't maybe essential, but they make a lot of sense, that came out of the Smalltalk designs, and some of them have pros and cons. So one thing is this notion of images or snapshots, right? One of the things about Smalltalk is you can save the state of your process, the interaction, wherever it was, to a file and then bring it up again sometime later. So you're getting on a plane, people force you to shut down your computer, you are in the middle of a debugging session, that's fine. It'll be there exactly as you left it when you bring it up, right? If you think of the analog where our standard model of programming is just talking about dead text, then of course text, yeah, we can save that in a file, we can send it to people, there are tools that will reopen that text, right? But if our model is that what we're really programming against is a live process that's dynamic in time, then that is something we should be able to save and reopen again at another point in time, right? We can probably do that. So if we go to one of these guys, let's change something obvious about the state here. Well, actually, we have changed, right? This is not the version. If I close this without doing anything, and I choose not to save, And I go back to somewhere here. I'm going to find a window where this baby came from. And I start it up again. And you'll see that all is well, right? This is not the changed one that I had. On the other hand, if I do choose to change it, and I quit now, and I save, and I bring it up again, there it is. So if something seems buggy because it probably, when it starts up, it's got issues about screen coordinates, so this thing seemed to move. But it does, it's basically exactly where we left it. And that is a very nice property. In Smalltalk, it's a double-edged sword because basically they overcapitalized on this idea. There isn't a real, because in Smalltalk, the whole model of programming is that it isn't the program text that matters, it is the live interaction of the objects. Basically, there's a notion of a sea of objects that are interacting, and that's your computation. And saving an image saves that. And they didn't even bother having a real syntax for your complete program. There's syntax for individual methods in Smalltalk, but there isn't actually syntax for a complete class or a complete program, which has led to all kinds of problems with, integrating with source control, whatever. That's one of the things that we do differently here, say, with Newspeak, where there actually is a syntax. So you can take the live thing, I wouldn't say too far, but you should not ignore lessons from the existing conventional world, which are useful things, that having a standard, text representation of your program is a good thing. But because of that, they've evolved all these interesting tools that let them, do things that you don't usually see. So one of them is snapshots, which are really good to have, but if it's all you have, you run into problems because it makes it very hard to separate your program from that process state, and it's valuable to be able to do that. So I wanted to mention that. So other properties, right? If, again, we're talking about the live program, the state, so we basically have a heap that's running, and we should be able to explore that. And there's some things that, unless you put them deep in your system, you're not going to be able to do, right? For example, if you want to see all the instances of a given class at a given point in your computation, most systems will not let you do that under any circumstance. There just isn't a mechanism to do that unless you explicitly write code to store them away, in which case you have a storage leak, and okay, maybe you can do a weak instance, but again, that's still occupying a lot of overhead of extra pointers. That stuff is in memory, and essentially the runtime system can get at it, right? And that's not a theoretical thing, because you get into one of the things that these systems can do is it's not just about evaluating expressions live, right? If I want to change a class, if I want to add, it turns out I have to make a modification, a refactoring, whatever. I have to add fields. In Smalltalk, I add a field to the class, and all the instances in the heap now have that field, right? Now, once you've done that, the question is, well, what state is that field in? What do I store there? By default, it's nil, but you probably want to put something in. Do you have a mechanism for actually setting all these instances to something sensible? So being able to get at all the instances is one mechanism that'll help you do that. It's a low-level mechanism, it's a primitive mechanism, and it brings up all kinds of interesting questions when you scan the heap, like, are all these instances live? Because if you're doing a scan of memory, there may be objects in there that are actually not live but haven't been collected yet. So there's all kinds of subtleties. None of this stuff is necessarily as easy as it looks, but the beauty of Smalltalk is they make it look easy. Similar, there's this magical operation called become that'll basically let you swap the identity of any two objects. So you can basically migrate things. And there's really interesting things you can do with that. If you're doing sort of orthogonal persistence, and you have these objects that are supposed to dynamically load stuff from persistent storage when they're used. Well, it's really, basically, they're acting as a proxy that when someone actually tries to get at them, they go off and load, persistent storage. You get into all kinds of problems with proxies with identity, but you can actually swap the identity and turn the proxy into this new object that you've loaded. There's all kinds of cool system-y tricks that let users without deep access to the runtime and to virtual machines and so forth build interesting systems because the internals of the system are exposed and manipulable and have powerful primitives to handle them. So all these things should not necessarily be reinvented. They do have to be controlled carefully because there's lots of issues. Smalltalk was designed in an age where people thought about how to teach children to program. They didn't think about, criminals in all kinds of obscure corners of the world writing viruses. That is one thing they didn't really foresee. And so a system like this is not trivial to secure, shall we say, right? Think of it. If I send you an object, if I call you with an object, and I tell you, here's this object, call it, and then you can actually get at its class, change its class, and that change not only changes this object that I gave you, but all the other instances of this object that you might have anywhere else. There are people who might say that this is not the most secure way to do business, right? Now, there are answers for that, which are way outside the scope of this talk, mirror-based reflection capabilities, etc. But actually building systems that answer all these things, there's a lot of open questions. There's this issue of keeping your process and the code in sync, right? So you have this thing that evolves in some state, and you change the code. The state you're in isn't necessarily the state you would reach if you started that code from scratch. It's amazing how often you can still, fix things and do things in development that are useful to you and shorten your development cycle, but you're never sure that this really worked if you started the program from scratch, unless you really do start all over again, which is the thing we've been trying to avoid. Ways of doing that are interesting. Other issues is we want all the code views to be live, right? So, wrong button. We look at this guy, any one of these guys, right? Let's find a class that's more conventional. So this is a view of a method in some actual class. Object-subject is sort of the thing that's behind the object presenter. The object presenter is what you'd call a view, and this is whatever you want to call it, a controller or a model view or all kinds of terminology for that. But the point is, this is dead code, right? If I want to evaluate this is a property of an instance. Which instance am I talking about? I mean, it's one thing to say I have some fixed code like set new where I might know what set is, but if in fact we can do this in the, let's look at this guy, right? So if I try to evaluate empty, which I think is an instance file, it gives me this error, right? We don't know what you're talking about because these are instance properties and I don't know what instance you're talking about. This is something that I think is still wrong in these systems. I think that you should never, ever look at dead code. Whenever you look at a piece of code in an editor, there has to be live data that you can experiment with so you can evaluate any sub-expression at all times. So the question is, how do you fill that in? Where do you get such data? Tests are a really good idea. You can get a lot of data from tests. There's even an argument that you should actually require your programming language to associate some sort of test expression with every method or something so that you always have an easy way to get this data. Otherwise, your environment has to go to some work to correlate tests with code and figure out what it is. But there are interesting questions to be done there, and we're going to see people solve that in the next few years, I'm pretty sure. Whoops, not that. So what else will we see? We're going to see time-traveling debuggers become real. And again, there's this whole problem of this that makes them hard is recreating the state efficiently at different times, right? You want to be able to move back in time and ask, set this variable that now has the wrong value? How did this happen? And kind of basically debug backwards. That's invaluable. It's a lot easier in certain functional settings. There's a nice system called Elm that I recommend you look at, which actually does this. And it's currently targeted just at UI, but I'm sure it'll evolve. And generally, it may be that live programming is actually the killer app for functional programming. The funny thing is the academic functional programming community doesn't understand this at all. And in fact, with the renewed interest in live programming, they've become aware that it exists. The general trend is to regard it as a fad and hope it will pass. But I think that the real hope for functional programming is the languages that are out there that people are building outside academia, which are taking some of the best ideas from functional programming but actually ignoring a lot of the unfortunate ones. And so we're quite likely to see a lot of this actually in the functional world. And I think we are just about 40 minutes and out of time, and that's all I had to say. Thank you very much.